Hey guys, Mr. Wigand. Today we're going to look at an intro to proportional relationships. Alright, so proportional relationships. A proportional relationship between two quantities is one in which two quantities vary directly with one another. If one item is doubled, the other related item is also doubled. Because of this, it is also called direct variation. Okay, so we see some terms in here that we're not probably familiar with, but you'll get used to as we use this more. And you'll notice that even though a lot of this seems new, you will find that there's a lot that you're already familiar with. All right, so here's an example. Days in one column, number of pretzels eaten in another column. So after 1 day, 4 pretzels are eaten. After 2 days, 8 pretzels are eaten. After 3 days, 12. And after 4 days, 16. This would be an example of a proportional relationship. And where I can kind of see this is, it says here, if one item is doubled, the other related item is also doubled. All right, well, it doesn't always have to be doubled, but that's what we're looking for here. So here, you're multiplying 1 times 4 to get that. And if you do the same thing, multiply by 4, you should get the number in the second column. If that happens, then yes, this is a proportional relationship because you're multiplying by the same number each time. All right, there's something called the constant of proportionality. And we're going to use the letter K for that. And K equals y over x. We'll see how we're going to use that. So we go back to that same example. And remember, everything in this first column is our x value. Everything in the second column is our y value. So now we want to find that constant of proportionality. So K equals y over x. So let's start with this first ordered pair here. And we get K equals 4 over 1, which is 4. Okay, now, since I already know this is a proportional relationship, I don't really have to check all of them. But if I didn't know, I could check all of them. And I would do 8 over 2. I would also get 4. I could check the next one, 12 over 3, which is also 4. And then the last one, 16 over 4, which is also 4. So I get the same constant for each one. Either way, our constant of proportionality is K. Now, another way to think about that, other than y over x, it's kind of go back to what we did before. What am I multiplying this by to get that? I multiply by 4. Okay, that's also the constant. So I can think about it, what am I multiplying the x value to get the y, or I can think about it with this y over x. All right, now we also look at proportional relationships in terms of graphs. The last example was a table. There's a lot of different ways we can represent it. This is just another. So basically, there's two things that I'm looking for if I want to see if a graph has a proportional relationship. The first thing is that the graph goes through the origin. And right here, it does. So at that point, 0, 0, if the line or ray in this example goes to the origin, then we're good. The second thing we're looking for, that it is a straight line. Okay, we don't want any curves, we don't want any bends, just a regular straight line. And in this example, we have both. We have it goes through the origin and it's a straight line, so this would be an example of a proportional relationship. Now, I could also double check this by making sure that my constant of proportionality is the same for each one of these points. I'll just take a look at those first three. So once again, remember we learned that K equals y over x. So this point right here is 1 comma 0.75. So I could do 0.75 over 1, which is 0.75. Right, this point right here is 2, comma 1.50. So I could do 1.50 over 2. 1.50 divided by 2 is 0.75. I get the same thing. And then this point right here is 3, comma 2.25. And if I did 2.25 over 3. Once again, I get 0.75. So I could check to see if they have that same constant, or like I said before, if it goes through the origin and it's a straight line, then it's going to be a proportional relationship. All right, proportional relationships follow a certain equation, y equals kx, where once again k is our constant of proportionality. So we're going to write some equations. We're going to look at a graph, we're going to look at a table, and we're also going to look at just like a word sentence. All right, so we want to write that equation. So remember, we need y equals kx. So basically what we need is the k. So we come over here, we want to find our constant. So remember, this is our x, this is our y. And we already know this is a proportional relationship, so I really only need to check one of these. Any one will work, since they're all going to be the same constant. And we learned that k equals y over x. So y is 1.50, x is 1, and I get just 1.50. So I can plug that in for k, and I get y equals 1.50x. And that's my equation. And that would work for all of these. If I plugged in 2 for x, I would get 3. If I plugged 3 in for x, I would get 450. If I plugged 4 in for x, I would get 6. All right, now we have an equation. All right, so once again, I want to write this y equals kx. That's how we write our equations. And we need to find k. And k is y over x. Okay, now, another thing about our constant proportionality is it turns out it's the same as finding a unit rate. So that's another way to think about these. When you're finding that constant of proportionality, you're really finding the unit rate. And on a graph, that's nice to know, because if you can find a point that matches 1 on the x-axis, and we do have one here, then that's really easy, because this is going to give us our unit rate. Remember, unit rates are, comparison of something over 1. So that point right there is 1, 4. So I can see it goes with 4 right there. So really, I could think of that as the unit rate 4 over 1, which is 4. Okay, once again, using k equals y over x, it would be 4 over 1, and I get 4 the same way. So just another way to think about it. Constant of proportionality is the unit rate. Right now that I have 4 as my k, I'll rewrite my equation, y equals 4x, and there's my equation. All right, last one. Write an equation for each proportional relationship example. This one is just words. Mrs. Miller can sew 10 scarves in 4 days. Okay, this time we're going to let S equal number of scarves, and we'll let D equal number of days. All right, so here's our formula, y equals kx, or our equation. But this time, we're given things with certain variables to use. So instead of y and x, we're going to be using s and d. All right, so for this one, we're going to rewrite this s equals kd. Okay, d is going to be our independent variable, number of days. That could be anything. And then s is going to be our dependent variable, because it depends on how many days that Mrs. Miller is sewing. All right, so now I only have 2 numbers to work with, 10 and 4. So 10 is the number of scarves, that's our S. I'm going to plug that in there. And then 4 is our number of days, so I'm going to put that in for D. And then we have a K there. We can divide each side by 4. And 10 divided by 4, we can say 2.5. Okay, once we have that, then we have our equation. Oops, whoa, we're not using that. We're using S equals, K is 2.5, D. And that's our equation there. All right, so that's a little intro into proportional relationships. You saw some examples of deciding whether something is a proportional relationship, deciding whether something's not, and we looked at tables, we looked at graphs, and then we wrote equations from a table, from a graph, and then from a word sentence here. All right, good luck, guys.